Hey guys, sorry I'm not here today. I had a really bad migraine, had to go home early. So what I decided to do was I'm going to teach you guys the lesson that I was going to teach you on Friday on 6.4, meaning that tomorrow we'll do our review for the test. I will have a help class tomorrow, which is Thursday, and then we will take our test on Friday. So what I did is I switched the days around so that I could still do a help class and still be there when you guys take your test. So again, help class tomorrow on Thursday. We'll do an in-class review, and then your test will be on Friday. All right, you guys should already have the 6.4 notes, so go ahead and take those out, and we will work on filling those in. All right, so we've been talking about polynomials, and we've learned how to multiply polynomials together by when you have like terms, when you're multiplying like bases, you add the exponents. Today, we're going to talk about how to multiply polynomials together. So on example 1, which you should have written down already on your paper, we are multiplying these two polynomials together. Now notice each of them has only one term. So what we're going to do is we're going to first start with multiplying the constants together. So we take 4.1 times 6, which gives us 24.6. So first start by multiplying the coefficients together. Once you've multiplied the coefficients together, then you're going to go ahead with every like base, you're going to add the exponents. So for the x's, we have x to the first times x to the first. So we're going to add those exponents. 1 plus 1 gives us 2 x's. For the y's, we have 2 and 5, which if we add those together gives us a total of 7. Finally, with the z's, don't forget this is z to the first. When we do our z's, we have z to the 10th, and then we have z to the first, which gives us a total of 11, because 10 plus 1 is 11. So our final answer is 24.1 x squared, y to the 7th, z to the 11th. That is how to multiply two monomials together. Now notice in example 2, we're multiplying this monomial by a binomial because there's two separate terms separated by a plus sign. So in this case, we have to remember our friend, the distributive property. The distributive property says that you multiply what's outside of parentheses by everything inside of parentheses. So we're going to distribute the negative 2b squared z to both the 2z squared a, oh, sorry, this is a trinomial, the b-a-z and the negative b. It's a trinomial because there's 1, 2, 3 terms separated by a plus sign and a minus sign. All right, so let's go ahead and distribute out. So we're first going to start with the first term, negative 2 times 2. So multiply your coefficients together first. Negative 2 times 2 is a negative 4. Then go ahead and do your variables. Now, like I told you guys, I do like to do them in order. So our first variable is an a. There's no more a's here, so it's just going to be a. Then I notice there's a b squared, and I notice there's no more b's. So I'm going to put b squared next. Finally, we have a couple of z's, so I'm going to write a first power here. And I'm going to highlight them because we're going to be adding their exponents. So for the z's, we have z to the first and z to the second. If we add those exponents, 2 plus 1 gives us z to the third. All right, moving on to the middle term. With this one, there's an understood 1 here, but when we multiply the coefficients together, 1 times negative 2 is just going to give us negative 2. Now let's do our variables. A comes first, and there's no a's here, so it's just going to be a. Then b. I have b squared and b to the first. 2 plus 1 is going to give us 3b's, or b cubed. Finally, there's a couple of z's as well. Z the first times z to the first, 1 plus 1 gives us z to the second. All right, on our final term, it's just a minus b. So first start again by multiplying your coefficients together. So we have a -2 times a negative understood 1. A negative times a negative will give us a positive, and 2 times 1 is 2. Now we go ahead and do our variables. The first variable is going to be a b. There's no a's, so going in alphabetical order, we have b to the first times b to the second. 2 plus 1 gives us b to the third, and then we just have a z. So I'm going to write 2b to the third z. Finally, we would combine like terms if there's anything exactly alike with the same variable, same exponent. This has an a b squared, and z cubed. This has an a b cubed, z squared. So in order for us to combine like terms, the powers on each variable have to be the same. But look, guys, they're not exactly the same. There's nothing exactly alike. So we would leave this just as it is. All right, moving on to the next one. It says, hint, use the distributive property twice and then combine like terms. So on example 3, notice we're multiplying a binomial, meaning 2 terms separated by minus sign, by a trinomial, meaning 3 terms separated by a minus and a plus. Here, again, we're going to have to distribute the x to all of these guys. We're also going to have to distribute the -3 to all of these guys. So you could do this a couple of different ways. Again, we all learn a little bit differently. So because we have to multiply the x by all of these guys, what you could do is you could write it as x times 2x squared minus x plus 5. Then we have to distribute the -3 to all of those guys as well. So -3 times 2x squared minus x plus 5. Now you could either write it out like that separately, where you multiply everything in the first parentheses by everything in the second parentheses. Or the other way you could do it, which is actually the way that I do it, is you could first multiply the x by all 3 of these. Then you could multiply the -3 times all 3. Now again, whichever way makes more sense to you. Some of you guys are going to want to write it down like this, where you break it up and then multiply. Others are going to want to get straight to it. All right, so if we do it the first way, I'm going to distribute out the x to all 3 of those terms. Now the coefficient here is 1, so it's going to take all of the coefficients of the numbers it's being multiplied by. So it's going to be 2x to the 1 plus 2 is 3. Then minus x times x is going to be x squared. And finally, when we multiply the x by the 5, it's going to be plus 5x. For the second multiplication or distributive property, we're going to multiply the -3 by all 3 of these guys. -3 times 2 is -6, and then we keep the x squared. -3 times -x, a negative times a negative is going to be positive 3x. Finally, this last guy, -3 times 5 is going to give us a -15. Finally, if we go ahead and combine anything that's alike, we have a -x squared, a -6x squared. We also have a 5x and a 3x. So our final answer is going to be 2x cubed. -1 minus 6 is -7x squared. Notice, guys, when we combine like terms, we don't change the exponent. Keep the exponents the same, just like we said yesterday. Finally, 5x plus 3x gives us 8x's. And And don't forget about the constant, and that is our final answer. Now again, we could have just gone straight to it, multiplying the x by all three terms, and then the minus 3 times all three terms. We didn't have to separate it like I did here, but for some of you, it's going to help you to separate it. All right, now when you're multiplying two binomials together, yes, you can do what I did above, you can distribute, but there's also another way that you can do that. It's called FOIL, and you probably remember this from Algebra 1. FOIL stands for first, outside or outer, depending on how your Algebra 1 teacher taught it, inside, and last. And it's a fun way to help you remember how to multiply two binomials together. Remember, binomial means two terms. So by first, it means the first term in each parenthesis. So we multiply x by 3x. X times 3x is 3x squared. By outside, we mean the numbers on the outside of each parenthesis. They're the ones that are farthest away from each other. So the ones that are farthest away from each other are the x and the negative 4. X times negative 4 is negative 4x. Inside are the ones closest to each other. They're in the ones in the middle. Positive 3 times 3x is positive 9x. And finally, the last are the last one in each parenthesis. The last on the first parenthesis is 3. The last on the second parenthesis is negative 4. 3 times negative 4 is negative 12. Finally, if we combine those two like terms, those two middles, negative 4 plus 9 is a positive 5x, and that is our final answer. Now, if you don't like the acronym of FOIL or you don't understand it, you could do what I did above, which is you could have separated it as x times 3x minus 4 plus 3 times 3x minus 4. So you could have multiplied everything in the first parenthesis by the second parenthesis. Again, both ways will give you the same answer. So if you had done it that way, you would still get 3x squared plus 5x minus 12, whichever way makes more sense to you. So again, we all think a little bit differently. So I'm trying to give you a couple different ways and latch on to the one that makes the most sense to you. All right, for example 5, I'm going to again use the FOIL acronym first, outside, inside, and last. Notice you're going to multiply everything together. The firsts are our first in each parenthesis, 3x squared times x squared. 3 times 1 is 3. And if we add the exponents, 2 plus 2 gives us x to the 4th. For the outsides are the ones that are farthest away from each other, which are the 3x squared and the negative 6y squared. Multiplying our coefficients together first, 3 times negative 6 is negative 18. We don't have any like terms. We have an x squared and a y squared, so I write my x first and then my y. The end sides are the ones in the middle, the ones closest to each other, which are these guys right here. Negative 4 times 1 is negative 4. We have a y squared and an x squared. I am going to write my x squared first, and then my y squared. Finally, the lasts are the last thing in each parenthesis. The negative 4y squared and the negative 6y squared. We begin by multiplying the coefficients. Negative times negative is a positive. 4 times 6 is 24. There's 2 y's and 2 y's. 2 plus 2 gives us a total of 4 y's. Now the final step to finish this up, we do want to combine like terms, anything with the same variable, same exact exponents, which these two middle terms happen to have. So if we go ahead and add or subtract the coefficients, negative 18 minus 4 is negative 22, and keep your exponents and variables exactly the same, don't add them. Finally, don't forget about the 24y to the fourth. And that's it. All right, now sometimes these binomials will be written a little bit differently. If you ever have a binomial, meaning two terms, squared, there's a way that you can do this without actually having to write it out twice. All right, so whenever you have a binomial squared, first thing you're going to do is take the first term and square it. X squared is just x squared. Then you're going to square the last term. So we take 2 and square it. 2 squared is 4. Finally, it says multiply the two terms and double. By double meaning multiply it by 2. So if we multiply these two together, x times 2 is 2x. But we can't forget to double. If you double 2x, you get 4x. Finally, I do like to write these in order. I'm going to put the 4x before the constant. Now, if you don't want to remember that or don't like doing it that way, you could always write this out twice and FOIL it. First, outside, inside, and last. And when you combine the like terms, you still get the same exact order. Whichever way you prefer, go ahead and use. I'm going to do that process one more time for example 7. Square the first. X squared is just x squared. Square the last. Negative 4 squared, and negative times a negative is positive 16. Then multiply the two terms and double. X times negative 4 is a negative 4x, but if we double negative 4, it's going to be, sorry about that, a negative 8x. Finally, I do like to rearrange it, so I'm going to write the minus 8x in the middle. I know some of you guys are going to ask, would I mark it wrong on the test? No, I will not mark it wrong on the test if you leave it like this. I would suggest getting in the habit of writing it in order like that, because when we go on to factor later on and do some other things, it's a little easier if you have it written in order already. All right, now if you're multiplying two binomials that are exactly the same, but the middle sign is different, there's a shortcut for that. So for example, if you have x plus 10 times x minus 10, there's a shortcut besides FOILing, but they have to be exactly the same. Notice how we have x's and 10s. The only thing different about them is the plus and minus. We do call this the difference of squares. So when you have a difference of squares where you're multiplying the same exact thing minus the signs, you square the first term, square the last term, and put a minus sign in the middle. So what's going to happen is when you FOIL this out, let's go ahead and do it. X times x is x squared. X times negative 10 is negative 10x. 10 times x is 10x. And 10 times negative 10 is negative 100. What happens when you have the difference of squares is your two middle terms will always cancel each other out because they're always going to be the opposite of each other. And you're just going to be left with the first term squared minus the last term squared. So it's just a little shortcut where you don't have to actually FOIL it out. So we square the first term. We square the last term. We put a minus sign in between them. Again, guys, like I said, if you don't want to use the shortcut, you can always first outside, inside, and last them, and you will get the same exact answer when you combine like terms. We're going to do that one more time for something that is a little bit more complicated. We have 6 minus 2b minus 2 squared. So we could consider this as a binomial squared. So when we have a binomial squared, square the first, square the last, multiply the 2, and double it. So if I square this first guy, 6 squared is 36. If I square the last term, all right, on second thought, I am going to write this out twice because I don't want to make it too complicated. Thinking about it, it's a little too complicated. So what we're going to do is remember that a squared means that you have the whole thing twice. So I'm going to write this whole thing out twice. So this one's a little bit more complicated. So if we go ahead and multiply them, we can FOIL first. 6 times 6 is 36. Now when we do the outside, we're going to multiply that 6 times the negative 2b minus 2. So that 6 is going to be in front of this 2b minus 2. So it's negative 6 times 2b minus 2. I'll do that multiplication in a minute, but essentially it's that 6 times that whole thing. So what I did is I threw that 6 behind the negative sign and put what was in parentheses. For our inside, we have this whole guy times this. So again, we're multiplying a 6 times the negative 2b minus 2. So that's going to be a negative 6 times 2b minus 2. And finally, for the last, let's do the sign first. We have a negative. It's that times that. We have a negative times the negative, which is a positive. Then we're going to multiply the 2b minus 2 times the 2b minus 2. So on something this complicated, first thing I would do is just write it out like that. Just simplify it a little bit for yourself. Then we could go ahead and use the distributive property. Notice that's going to be the same thing. That's where that doubling idea comes into play. Negative 6 times 2 is negative 12b. Negative 6 times negative 2 is a positive 12. So you're going to see this twice. Negative 6 times 2b is negative 12b. Negative 6 times negative 2 is a positive 12. So notice these were the same. Finally, I'm going to FOIL this. Or you can use that whole thing. You can double the first, square the first, square the last, multiply the 2 together and double, whichever way you prefer. Either you want to FOIL it or do the shortcut. I'm going to do the shortcut. 2b squared is a 4b squared. We're going to square the second. Negative 2 squared is positive 4. Finally, we're going to multiply the 2 together and double. 2b times negative 2 is negative 4b, and negative 4b doubled is negative 8b. Again, if you don't like that shortcut, you can go ahead and FOIL it out. You should get the same exact thing when you combine like terms. Finally, I'm going to put it together, going from highest to lowest. Our highest degree is this 4b squared, and it's the only one. I'm going to write it first. Next, if we look at the b's, we've got negative 12b and negative 8b, which gives us a negative 20. Oh, and I missed one. All right, let's try that again. So for this one, we've got a negative 12 and a negative 12, which is a negative 24. Negative 24 minus 8 is a negative 32b. And finally, for all of our constants, but that wasn't supposed to happen, we have a 36, a 12, a 12, and a 4. And if we add those together, see, 36 and 24, and then we're going to have 4 is going to give us a total of 64. And I don't want to write that in highlighter. And that is our final answer. So notice we started simple by multiplying monomials together. Then we learned how to multiply a binomial by, or a monomial by a trinomial. We've learned how to FOIL. And finally, we're going to talk about what happens when you have more than one thing together. So we're multiplying 3 binomials together. So with something like this, you could do it again. These have so many different ways you could do them, but I would probably start by foiling these two together. So I would leave this in parentheses and just FOIL the second guys together. So if we FOIL these guys together, x times 2x is 2x squared. If we do the outside, x times -1 is -1x. For the inside, -2 times 2x is -4x. And for the last, -2 times -1 is a +2. So I would first start by FOILing the second set of parentheses together. And of course, before I do anything else, I would combine those like terms. So simplify as much as possible before you use the distributive property. -1 minus 4 is a -5x. All right, so I would simplify it that much first. Then I would go ahead and distribute this x to all 3 of them, then distribute the 3 to all 3 of them. Again, you could do this one of 2 ways. You can write it out like I did in the very beginning. So if you decide to write it out, it looks like x times all 3 of those things, and then 3 times all 3 of those things. Now I did it this way at the very beginning, so I'm going to do it the other way, the way that I actually do it. So how I would do it is first multiply the x by 2x squared, which would give us 2x cubed. Then I multiply the x by the -5x, which is -5x squared. And finally multiplying the x times 2, which is 2x. So I'd first start by multiplying that x by all 3 of them. Then, use a different color, I would multiply the 3 by all 3. 3 times 2 would give us 6x squared. 3 times -5 would give us -15x. And 3 times 2 would give us 6. I would finish it off by combining any like terms and writing it from highest degree all the way down to the lowest degree. Now you do need to combine all the like terms. You don't necessarily have it in order, although it's suggested, but please make sure that you combine all like terms. -5 plus 6 minus 5 is 1, x squared. 2 minus 15 is a -13x. And that would be our final answer. Now guys, this video will be posted on Moodle. I know I'm kind of going through a lot of material, but you can always go back and watch this video later on if you wanted to for practice. We're almost done with the lesson. On my next example, this is y minus 2 to the power of 4. Now 4 means that there's going to be y minus 2 times y minus 2 4 times. So essentially like this. So we could do it a couple of different ways. Now I could write it like that. Another way that I could write it is y minus 2 squared times y minus 2 squared, right? There's 2 and 2, which still gives us a total of 4 y minus 2's. So what I would do, what you could do, now you could multiply just like I did. You could FOIL, combine like terms, and then distribute again. You do it so many different ways, but one way that I want to show you, if you don't want to do it that way, is we could use our shortcut twice. So the shortcut says when you have a binomial squared, square the first, square the last. -4 squared is +4.
and then multiply the two together and double. Y times negative 2 is negative 2y. Negative 2y doubled is negative 4y. Now what's going to happen is when you do that with both of these guys, they're both going to end out up to be the same exact thing. So you're going to have that twice. Now I am going to rearrange the order because I like to have them in order. So I'm just going to switch around these two middle guys. And then I'm going to go ahead and distribute the y squared to all three, the negative 4y to all three, and the 4 to all three. So everything in the first parentheses gets multiplied by everything in the second parentheses. Y squared times y squared is y to the fourth. Y squared times negative 4y is negative 4y cubed. Y squared times 4 is 4y squared. Moving on to the middle, we're going to multiply negative 4y times everything, which gives us a negative 4y cubed. Negative 4y times negative 4y is going to give us a positive 16y times y is y squared. And finally, negative 4y times 4, negative 4 times positive 4 is a negative 16. But don't forget that little y stays attached. Finally, multiplying the positive 4 times all three of those. 4 times y squared is 4y squared. 4 times negative 4y is negative 16y. And finally, 4 times 4 is 16. Finally, there's some like terms to combine. I'm going to combine our y cubed. I'm going to combine our y squared. I'm going to combine our y's. And I noticed that I forgot a y squared, so I'm going to go ahead and highlight that one in green as well. So our final answer is going to be y to the fourth. For our y cubed, we have negative 4 minus 4, which is negative 8y cubed. For our y squared, 4 plus 16 is 20. 20 plus 4 is 24. Y squareds, don't add your exponents. Finally, for the constant, we just have that plus, oh, sorry, almost forgetting the y's. Negative 16 minus 16 is negative 32y plus 16. And guys, there's so many different ways that you could do it. You could have foiled, and then multiplied. But the important part is that you get the same exact answer. All right, finally, the last two examples are a little bit different, but it's just function notation or polynomial notation that we learned last time that we talked about yesterday. It says for function notation, it's written as a variable, and in parentheses, there's either a number or a letter. This is function notation. So whatever's in parentheses, you go ahead and replace your variable with what's in parentheses. So essentially, replace x with c. So instead of x squared, it becomes c squared. Instead of negative 2x, it becomes negative 2c. So whatever's in your parentheses gets replaced. So if we have something like f of a minus 2, we're going to use the same function. We use function f. But in place of x, we're going to put a minus 2. So it becomes a minus 2 squared minus 2 times a minus 2. So notice, guys, we are taking a minus 2 and replacing x with it. So everywhere we see an x, I put in a minus 2. Now that we've done that, we can go ahead and multiply. I'm going to use the shortcut, square the first, square, I don't know how to get that down, square the last. Negative 2 squared is positive 4. and then multiply the two together and double. Negative 2 times a is negative 2a times 2 is negative 4a. Finally, if we distribute out the negative 2, get negative 2a, and negative 2 times negative 2 is a positive 4. We finish it out by combining like terms. We get a squared minus 6a plus 8. All right, guys, so that is it. My video, that's it for today. I should be back tomorrow, and like I said, we're going to do our review tomorrow, and I will also have a help class. So I apologize, I couldn't be there today. I had a migraine, had to have my mom pick me up and drive me home, but I'm feeling a lot better, only have a little bit of a headache left now. So I should be back tomorrow. We'll do our review, and we'll take our test on Friday. All right, guys, I'm praying for you. I hope you have a blessed and wonderful day, and I'll see you tomorrow. All right, Vetter out.